Hey guys, welcome back to our channel, Java Folks. In this video, we will learn about Java introductions. James Gosling designed Java in June 1991, and his team was known as the Green Team at Sun Microsystems. The language was originally named Oak after an oak tree that stood outside Gosling's office. But the oak was a huge failure, because it is designed to handle portable devices and set-top boxes. In 1991, the C++ programming language was also widely utilized to develop machine programming. As a result, Oak was completely unnecessary. The Oak language was altered later in 1995 to benefit from the development of web-based business applications, since the internet was just being started at the time. Additionally, Gosling intended to rename the language. He therefore asked his staff to come up with a new name. Several names, including Silk, Jolt, Dynamic, Revolutionary, DNA, and others, were also proposed by the team. However, while sipping his coffee, Gosling made the decision to modify the name to Java. The reason for this is that Java is the name of an Indonesian island where the first coffee was grown. Thus, the name of the island Java became the language's name, and the coffee symbol became its emblem. Java is therefore not an abbreviation. Ultimately, the first Java version, 1.0, was made available in 1996 and quickly gained popularity. Java was first created by Sun Microsystems. After a heated dispute with IBM in 2009, Oracle Corporation later purchased it for $7.4 billion. Finally, Java is written in the C++ programming language. Why was Oak a failure language? The programming language Oak was a tremendous flop. It was first created to handle set-top boxes and portable electronics. However, in 1991, machine programming was developed using the C++ programming language, which was widely utilized for the same purpose. Oak was not needed in any form because its special portability characteristic was not needed at the same time. The language was altered to capitalize on web-based commercial application development, and the name was changed to Java later in 1995. Because the internet was only getting started at the time, there was a great need for Java's special portability characteristic, and Java quickly became well known. What is Java? Java is an open source, the high-level, object-oriented, robust, secure, and network-centric programming language. It is both a compiler and interpreter language. Java applications are called WRA, write once, run anywhere. This means a programmer can develop Java code on one system and can expect it to run on any other Java-enabled system without any adjustment. This is all possible because of JVM. Java is a platform-independent language. So Java works on different platforms like Windows, Mac, Unix or Linux, Raspberry, etc. Java is a multi-threaded language with automatic memory management. Java is created for the distributed environment of the internet or intranet. Java's syntax are similar to C and C++, but it does not support the pointers for security reasons. However, it is not a pure object-oriented as it provides supports for primitive data types like int, char, float, double, etc. The four types of Java platforms. The first one is Java Platform Standard Edition, Java SE. The Java SE platform offers APIs and the Java programming language's core functionality. It is used for networking, security, database access, graphical user interface GUI development, and XML parsing. The second one is Java Platform Enterprise Edition, Java EE. The Java EE platform offers APIs and runtime environment for developing and running highly scalable, multi-tiered, reliable, and secure network applications. The third one is Java Platform Micro Edition, Java Me. The Java Me platform offers APIs and a small footprint virtual machine running Java applications on small devices, like mobile phones. The fourth one is JavaFX. JavaFX is a platform for developing rich internet applications using a lightweight user interface APIs. It uses hardware-accelerated graphics and media engines that helps Java to take advantage of higher performance. It uses modern look and feel and high-level APIs for connecting to network data sources. The purpose of Java: constructing and executing mobile applications, developing and scaling cloud apps. applications of scientific computing, assisting with Internet of Things, IoT, and artificial intelligence, AI devices. Utilization in big data analytics. Hardware programming with Java. Utilized for server-side technologies such as Glassfish, JBoss, Apache Tomcat, and others. Creating chatbots and additional marketing resources. Creating web apps at the enterprise level. What is the JDK? The Java Development Kit JDK is a set of software development tools and accompanying libraries that includes the Java Runtime Environment, JRE, and Java Virtual Machine. The term JDK stands for Java Development Kit. The Java Development Kit JDK is a software development environment used for creating Java applications and applets. It contains JRE and developer tools. The JDK includes a private Java Virtual Machine, JVM. JDK's core components include an interpreter, Java, a compiler, JavaC, an archiver, jar, and a documentation generator, Javadoc. JDK exits in three forms. The first one is Standard Edition, Java SE. The second one is Enterprise Edition, Java EE. The final one is Micro Edition, Java Me. Here are some of the key components of the JDK. Applet Viewer. Run and debug Java applets without a web browser. The Java compiler, JavaC, turns Java source code into Java bytecode. The tool name. Java is an interpreter that can interpret class files created by the Javac compiler. Javadoc is a documentation generator that generates documentation automatically from source code comments. Jar. It packages related class libraries into a single JR file. JavaH allows you to write native methods in the C programming language. JavaP is the class file decompiler or disassembler. JConsole, Java Monitoring and Management Console. JDB, the debugger. Visual VM is a visual tool that combines numerous command-line JDK utilities plus a memory monitoring system. What is the Java compiler? A Java compiler, JavaC, is a program, command-line tool, or component included with JDK. The Java compiler converts a developer's Java text files into platform-independent Java class files. That is, it converts the Java source code to bytecode. There are three types of compilers. The first one is the Java Programming Language Compiler, JavaC. The second one is called the GNU compiler. The third one is the Eclipse compiler for Java, EastJ. What is the Java interpreter? A Java interpreter is a software, command-line tool, or component included with the JDK. An interpreter in Java is a program that transforms bytecode to machine code. It is intended to read the .class file and then convert the bytecode instructions one by one into machine code. When a program is run, an interpreter transforms the bytecode to machine code in parallel. Important points about the interpreter. During runtime, the interpreter converts the bytecode line by line. If we use an IDE, such as Eclipse or NetBeans, we can execute and evaluate source code step by step. The interpreter can only display one error at a time. When compared to a compiler, program execution time is slow. What is the Java decompiler or disassembler? A Java decompiler is a sort of decompiler that accepts a class file as input and returns Java source code as output. Decompilation is the reverse of compilation. The decompiler does not make a copy of the source code. It is because certain information from the source code is lost during the program's compilation. The JavaP is a Java command line tool included with JDK. It disassembles the class file and outputs a human-readable version of the class. The output depends on the option selected. What is the Java JRE? The Java Runtime Environment, or JRE, is a software layer that sits on top of a computer's OS. For example, Windows, Mac OS, and Unix all have a JRE. JRE provides the class libraries and other resources that a specific Java program requires to run. JRE, like JDK, includes Java class libraries since the predefined class libraries used by the Java program are required at runtime. Next, the four main components of JRE. The first one is class loader. The second one is bytecode verifier. The third one is an interpreter. The fourth one is JVM. Next, the functionalities of JRE. The JRE combines a class file or bytecode file, with the Java predefined class libraries required for execution on a JVM. The JRE loads classes, monitors memory access, and obtains system resources. The JRE then launches an instance of the JVM, which runs the class or bytecode file. How does the JRE work? The Java class loader dynamically loads all the classes required to run a Java program into the JVM. Java classes are only loaded into memory when they are needed. The JRE employs class loaders to automate this procedure on demand. The bytecode validator guarantees that Java code is formatted and accurate before it is passed to the interpreter. If code violates system integrity or access privileges, the class is considered corrupted and cannot be loaded. After the bytecode is successfully loaded, the Java interpreter generates an instance of the JVM, allowing the Java program to run natively on the underlying computer. What is a JVM? The Java Virtual Machine, JVM, is an abstract machine. It creates a runtime environment in which Java bytecode can be executed. JVMs are available for a variety of hardware and software platforms. The JVM is platform-dependent. JIT stands for Just-in-Time Compiler. JIT is a component of the Java Virtual Machine, JVM. It is used to accelerate the execution time. JVM is written in C and depends on the operating system. JVM is a program that runs live Java applications. Every JRE has a default JVM. JVMs differ between platforms. The JVM is responsible for allocating the memory required by the Java program. The JVM manages memory space using garbage collection. What is a just-in-time JIT compiler? The JIT compiler operates inside the JVM and compiles the bytecode to real machine code in parallel with the program execution. When an interpreter executes Java bytecode, the performance is always slower than when the same program is compiled into native machine language. JIT compilers for executing Java bytecode help to alleviate this issue. During program execution, a JIT compiler may transform Java bytecode into native machine language. The translated components of the program can therefore be run much faster than if they were interpreted. This approach is used on the most often run elements of a program. That is for hotspot codes. Hotspots are the areas of a program that are most frequently executed. This allows a JIT compiler to dramatically reduce total execution time. Thanks so much for watching. If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more videos. And hey, let me know your thoughts in the comments below. I'd love to hear from you. Make sure to hit that notification bell so you don't miss any updates. Until next time, take care and see you soon.